Converting quadratic forms, pre-calculus, pre-college math. This is really an extension of the completing the squares video, the previous video. So what we're asked to do is to put the following quadratic into this form. This is called the vertex quadratic form, and we're going to learn more about interpreting what this form actually means in the next video. We're going to have a video dedicated to just reading what all these things actually mean, and I may talk a little bit about it here. But really what we're trying to learn today is how do I get this to look like this, and essentially it is the process of completing the square, except we don't go quite as far as we did in the previous lecture. So well, let's get started. So first of all, I have y equals here, but I can really just interpret it as a 0 equals, and in the same process, I'm just completing the square. I need to get the constant here to the other side, so I'm going to rewrite this as x squared minus 6x equals negative 14. And again, we know that we can't have a number in front of x squared, but there isn't right now. Well, we know there's a 1 there, but I mean, if there's a number besides 1, then we divide it away, but we're good with that so far right now. Then we have the b divided by 2 squared steps, so we are going to add 9 to both sides because that is your negative 6 divided by 2, and that'd be negative 3, and that squares to positive 9. So we add 9 to both sides. So adding 9 to both sides, keeping our equation balanced. Then we get the factoring step, and this particular one would be x minus 3 squared. And remember that step is it's basic factoring. You're just looking at this trinomial over here on the left. It would factor to x minus 3, but we write it as x minus 3 squared. And the real mental shortcut to that is knowing that this here, this term is simply this term divided by 2. It's your b divided by 2. And so you can really just jump right to that if you recognize that. And that's very helpful also when it ends up working with fractions and so on. And then cleaning up this right side, negative 14 plus 9 is negative 5. Okay. Now, for completing the square, what we were doing yesterday is we went further with this. We then square root both sides, got a plus or minus, and so on and so on. We're actually going to stop here as far as completing the square is concerned, and then set it back equal to 0. Stop and set equal to 0. And so what I mean by that is we kind of move, our first step was to move the constant away. Well, now we're going to move it back. And so I'm going to change this to be parentheses x minus 3 squared plus 5 equals 0. And I can now, again, go back to what my first thing I did was I replaced my y with 0. Well, now I can replace it back with a y. So I end up with y equals x minus 3 squared plus 5. And that's my answer. That's actually what I'm looking for here, is I'm looking for it to look like this. We're familiar with the quadratic form of the, A, B, C quadratic notation. Well, this is the a parentheses x minus h squared plus k notation. And what's helpful about this is if you remember the first thing that we did when we started this chapter is we did transformations. And this transformation would translate to a minus 3 inside would mean right 3, and a plus 5 outside means up 5. And what this actually does is it tells us the location of the vertex of our quadratic. And so our quadratic's vertex is at the coordinate 3, 5. Because from our standard just x squared parabola, we move to the right 3 and up 5. And so that's why we started this chapter doing transformations, so we could kind of make sense of what this means. And then, we see up here that this notation, our vertex, and again, we're going to have a video dedicated to this, but our vertex is hk. It is the opposite sign of this and this. And the reason why it's the opposite sign for h is because remember, when you're inside the parentheses, minus means right and plus means left. So it's kind of opposite of what you think it is. So it's the opposite sign of h, and then k is what it is. And then you're also going to learn about the axis of symmetry. And that's basically a vertical line that cuts it in half. It's simply x equals h. So our axis of symmetry here, I'm just going to abbreviate AOS for this particular problem, would simply be x equals 3. So once you have this vertex form, you can kind of answer some key questions about what was the transformation that got you away from the origin, where's your vertex now, what's the axis of symmetry. So it's actually a much more useful way of expressing quadratics than the standard ABC notation that you are accustomed to. All right, let me give you one more example real quick. All right, so here I'm going to, again, just think of this as 0, move this constant, so it's going to be x squared plus 5x equals negative 7. The b divided by 2 squared is, let's see, this is going to be an odd one. It's going to be a fraction. 5 divided by 2 squared is 25 over 4. And so we have negative 7 plus 25 over 4 on this side also. Factoring, again, with that mental shortcut's really not bad. It's simply my b term divided by 2. So that's a positive 5 over 2. And that parentheses being squared. And that equals, now this part here, I think most of you probably use your calculator for this. This fraction is equivalent to the same thing as negative 28 over 4. I'm just putting it over 1 and multiplying the top and the bottom by 4. And negative 28 over 4 plus 25 over 4 is equivalent to negative 3 over 4. But your calculator will do that algebra just fine for you. And now we stop with the completing the square. We're done with that. And move this back to this side. And set it as a y equals. So y equals, parentheses, x plus 5 over 2 squared plus 3 over 4. And I'm going to do one more thing, but also remember, this is the negative, so moving it back is making it positive and so on. But the last thing is notice that sometimes we have an a in front of the parentheses. Well, that results when this number here, k, is a fraction. We don't want that number to be a fraction. So what I could actually do is I can multiply both of these things by 4. And then I can actually rewrite this to be y equals 4 parentheses x plus 5 over 2 squared plus 3. So at this final stage, if you end up with a number down here, you can simply move it to be a coefficient over there. Because multiplying this by 4 cancels out here, and multiplying this by 4 is what makes it stick there. I don't multiply these pieces by 4 because that would require distribution, and I don't want to do that because I want to keep it like it is here. So this would now mean like a equals 4, the number in front of the parentheses, h equals negative 5 over 2. Remember the opposite sign in here because this actually means left 5 over 2. And k equals 3. So from this, I get my vertex, my axis of symmetry, and everything, and it talks about transformations, but that's the whole deal there. Okay, so that's pretty much what we're looking at in our next section here. Just converting these forms. You have a couple questions that ask specifically, like what's that k value on the end, and what's the axis of symmetry. So you got to get that h value in the middle, stuff like that. But we'll practice all this tomorrow. It's really just completing the square and then bringing it back. I think the one tricky part that you might struggle with in the beginning is just that if this is a fraction over here, this bottom number, multiply it to be the front over here, just like I'm showing you down here also. Okay, but we'll certainly practice this in class. See ya.